All right, folks, in today's lab, we're going to learn how to estimate a t-test and also a one-way ANOVA. So the first thing we're going to do is estimate a two-sample t-test where we calculate the difference in means and the number of deficiencies by government ownership, right? And so we do that with the t-test command, followed by the variable that we want to specify the differences in means for. So in this case, the number of deficiencies, and then comma, by, in parentheses, government status for values of 1 and for values of 0. It's the pooling of nonprofit and private nursing homes. So let's go ahead and run this, right? And what we see here are the number of observations for each group, right? And then the mean deficiency value for the public sector, which is 6.5 on average, and the mean deficiency level for the nonprofit and private sector is about 8.2. Now, what's important here is looking at this difference column, right? The difference between these two categories is 1.6 deficiencies. Right, and we also see 95% confidence intervals here, right? So this estimate ranges in the population from 0.37 all the way up to 2.8. Now, the most important thing here is this column here, which is our alternative hypothesis. And in this case, the difference between these two groups is not equal to 0, right? And we see a p-value of 0.01. Right? And this is less than our critical alpha value of 0.05. So we reject the null hypothesis that the difference of means is equal to 0, and instead conclude that there is a non-zero difference between these two groups. Right? Now let's do this same thing, but for the percentage of Medicaid patients. Right? Here we see a similar output. Right? The mean deficiency value for the mean percentage of Medicaid residents in public nursing homes is about 60.6% compared to the private and nonprofit group, which is about 61.7%. Right here, if we look at the alternative hypothesis, right, the p-value is equal to 0.6, right? So we fail to reject the null hypothesis, right? So we conclude that there's an inconclusive relationship here between the percentage of Medicaid residents and government sector, right? And this is further reinforced by the confidence intervals here, right, which range from -3 all the way to +6, right? So since 0 is included in that confidence interval, we would say that the relationship is inconclusive. Now, one of the things that we made one of the assumptions that we made for a t-test was equal variances. But we can actually relax this assumption very easily by adding the syntax unequal at the end, right? And this is probably the safer bet. And when we do this, right, we see that in general, the conclusions are fairly similar, right? We see slightly different p-values here and slightly different confidence intervals, but this does nothing in terms of changing the mean or the difference, right? All that we're changing when we specify unequal is a different calculation of the confidence intervals and significance testing. Now we're going to slightly shift over to a one-way ANOVA, and the first example here is going to show you that in the case of only two categories, a one-way ANOVA and two-sample t-test will yield equivalent results. So I'm going to estimate both of these here. And we'll start here with the command for a one-way ANOVA looking at the differences and deficiencies by government status. Right? And here we see the ownership categories. Right, so a value of 0 is the private and nonprofit sector, right? Their mean value is 8.2. If we go up here, right, see that's the same value here. 6.5 deficiencies for government nursing homes, that's down here. Same thing up here. Now, the other important thing that we want to pay attention to here is the between groups column, right? What this p-value here of 0.01 is telling us is that there is a statistically significant difference in the mean value between these two groups. Moving down here to this next model, which is looking at the percentage of Medicaid, right? We see it's statistically insignificant. Right? And if you looked at these two p-values and compared it to the p-values that were generated from our original t-test, you would find that those are the exact same p-values, right? So further showing that when you have two categories, we find equivalent results across these two tests. But so what we want to do now is look at all three ownership categories simultaneously. Right? And so let's first tab the ownership category, right? And we see that there's a sizable number of private, a sizable number of nonprofit, and a sizable number of public nursing homes, right? So treating them as two categories is kind of not letting us flesh out the nuance that could be reflected in the data. And so the first thing we're going to do is use this three category variable and define some labels for it, so it's a little bit easier to interpret. And we do this by first using this label define command, and we're going to create a label called sector, where values of 1 is equal to private, values of 2 are called nonprofit, and values of 3 are government. Right? So this is just putting a label over these values. So after we run that command, we'll run label list sector just to make sure it worked right. Right? And if we did it right, we would see that values of 1 correspond to private, 2 to nonprofit, and 3 to government. And now the final thing we want to do is actually attach this label to our 3 category ownership variable. And we do this by typing label, values, own3, which is the variable, and then sector, which is the label we want to put on that variable. Right, and just so we can see it, let's type tab own3 again. Right, and see now, instead of reporting 1, 2, and 3, it reports it as private, nonprofit, and government. Right, so one of the reasons we want to put labels on things is it's easier for our own interpretation, for 1, and then for 2, when we're making tables, we won't have to reword anything manually. Those labels will be reflected in any of our tables. So now what we're going to do is estimate an ANOVA, which allows us to look at all 3 categories simultaneously. So we'll first use the one-way command, def_num, right? We're specifying the mean value that we're interested in. And this is the categories that we want to look at these differences in means over, right? So the 3 ownership categories. And then we put comma tabulate. So what we see here is, right, the mean value for all 3 sectors of deficiencies. Right, and then the next thing we have down here is the between groups column, which tells us that there is a statistically significant difference between the means, right? But it doesn't tell us which 2 combinations or pairs are statistically distinct from one another. Right, and we do the same thing here for the percentage of Medicaid. Right, we see the mean values here, and then the difference between groups is statistically significant, right, with a p-value of 0.000. Now this tells us that a difference does exist, but oftentimes we want to make a multiple comparisons test because we want to know what sector specifically is distinct from another, right? Since we're dealing with 3 sectors, it's useful to know exactly where those differences lie. And so we do this by making a Bonferroni adjustment, and all we have to do beyond this initial command here is type in bon. And what this will do is make the Bonferroni adjustment. And so above here, right, we have the exact same output as before, but now we can make multiple comparisons, right? So the comparison between private and nonprofit, there's a negative 1.46 percentage point difference, and it's statistically significant. The difference between private and government is negative 2.1, and again, that's a statistically significant difference. But now if we look at the nonprofit and government, right, we only see a difference of 0.63, right, and a p-value of 1. So there's no statistically significant difference between the nonprofit and government sector on performance, right, which is something we couldn't quite glean from the earlier ANOVA. Right, and then finally, we'll do this command again with the percentage of Medicaid residents, right? Same output as we saw before, but now we have the Bonferroni adjustment down here at the bottom, right? So we see a significant difference between the private and nonprofit sector of about 16 percentage points. Private and government, we see about a 6 percentage point difference, p-value of 0.03, right? So less than 0.05. So again, statistically significant. And then finally, the nonprofit and government difference is about a 10 percentage point difference, which is again statistically significant.